So yeah, I'm Stephen. As you can see, I'm not an Erlang developer, unfortunately. So if you've got any really complicated Erlang questions, Thomas is right there. He's one of our Erlang developers. The other one is at home. So keep on spare. So yeah, I'm going to hopefully tell a story about what drove us to Erlang in the first place, and there'll be room for questions at the end. But also jump in, stand up, shout Steve, or I respond to Yo sometimes. Cool. So most of you probably won't have heard of Dataloop because we're still quite a young company. There's only 8 of us in total, and we've only been going for 2 years. The first year there were 3 of us, and we just really worked with one company. So what Dataloop does, it's a monitoring tool. We specifically cater for operations people or developers. So there are lots of monitoring tools out there that work with product managers and monitor social media. We don't do that. We help developers and operations people write code that then gets released normally online as a SaaS product. So what we do is it up or down? So we poll a lot of stuff. We also give you the ability to create flashy dashboards so you can tell how fast it's running, we'll make trends and do capacity. We'll alert you, we'll put the message into Slack or HipChat or whatever you guys use, or we'll send you an email. There's some unique stuff that we've got inside Dataloop that allows us to rapidly create new check scripts. So in the world of development, you guys are often writing unit tests, or you're writing custom code, and then you'll go off and write some tests to test it. In the world of DevOps and infrastructure, you're generally writing little custom scripts to test that your software deployment has worked. Is the load balancer working? Is your database working? Is your code working as the traffic comes all the way through the stack? So we let you create that stuff quickly. And then there's a load of, we're more targeted towards the enterprise end of things. So you can do all the boring stuff that you would expect in an enterprise product. Lots of logins and separating what the users can do and that sort of stuff. But the idea is it's a self-service monitoring tool for DevOps and operations teams running their business at scale, ideally. So, as I said, we spent the first year building Dataloop, pretty much behind closed doors, and we decided it was going to be scalable, so we built it in a microservices fashion. Now, we had basically one person using it, so we needed to build all this. It's the most important piece. So we split it all out thinking that would be infinitely scalable, and we could put as many users on it as we possibly wanted, and we'd never have to change any of the architecture. That was overkill, ideally. So we've got you probably can't see it, but that down there is a Rabbit bus. That's like our enterprise service bus. Everything talks to it. We did everything initially on NodeJS. Back when we started 2 years ago, that was like the best thing ever. Node and Mongo and the mean stack were like the best thing. And yeah, so you can see we've got a bit of Mongo in there, the application database. We used Riak as our time series database, mostly because we didn't have time to build our own, and the sorts of feature requests we were getting from our customers were not that complex. We just needed to take data and display it on a graph on the screen. We didn't need to do anything complex with it. We just, because it was operations first, it was just, can we get CPU, disk memory, RAM and things. As time's gone on, the features have been sort of changed. We've got a couple of mechanisms for getting data in. One of them is we wrote our own agent in Python. So we distribute that as like devs and RPMs and whatever packages. That runs on the servers, and that's what runs the scripts. So we can run our just check scripts. That will poll every 30 seconds, give us some text and send it back to us. We're also silly enough to let people just stream in data directly at any resolution to 1 second. But they can do that at massive quantities. So the use case for that's normally Graphite Stats D. You guys, anybody know what that is? Good. So, Season nodding.
Now you mention it,
yep.
Why was there a need to have something bespoke and not use what was available at the time?
For what?
For monitoring.
So we did a lot of validation. I mean, not many people like building stuff that nobody wants to use. So while we were at Alfresco, we were building this. Basically, we were building this system but using open source technology. So, and we actually talked to about 100 companies while we were there and just said, are you guys doing the same thing? And it's 80% of the time, we actually released all of our graphs on a blog. 80% of the time people were setting up Nagios for doing the polling piece. People were setting up Graphite and StatsD for doing the instrumentation of code. And it was the same old crap over and over. And they would not only build that stuff, they would then go on to build like a SQL reporting database with custom Ruby scripts, a cron job to do, and you end up with what we call the Franklin monitor. And even when you've spent 6 months building this thing, actually some companies spend 5 to 10 years building their own thing. Ticketmaster, for instance, have spent at least 5 years, what I know, building a monitoring system isn't quite alert yet. It'll just it'll take data and you can query it online. It's advanced. It's OpenText DB and it's got dimensions and it's really good for development stuff, but it's not the full bit. So you can spend a lot of time on this stuff. So we decided a while ago, you're probably not going to have one monitoring tool for everything. You know, we go into companies. Wouldn't it be nice if you could go and you could buy a New Relic or AppDynamics to do your APM monitoring? If you could buy like a Pingdom or a status cake for doing your external checking, and then something for doing your logs, like a Splunk or an Alp. You do all that, and then you've still got this mess left. That's the mess of open source. And it's good up until you get to about 50 developers and a few hundred machines. And then, even though you spend all that time on this stuff, it doesn't scale. Like, all of the databases that are available for time series, they've all got some very nasty trade-offs. So not only have we had to do this, but we've also had to pretty much start to contribute to a new time series database that I'll talk about at the end, written in Erlang, obviously, that's why I'm here. Trying to get more people to use it. But that one's got less bad trade-offs than all the ones that existed 2 years ago, but it's quite new. So, no, I mean, this was designed to be one of the three. You know, you go and you buy New Relic, you buy Splunk, you buy Dataloop, you've got most of your monitoring covered. There'll still be extra little bits, but we do that custom monitoring stuff that you would normally piece together. So if we look back, I mean, this was the first year. I call it the first year, but really, the first year was me, Colin, and David sitting on site at British Gas, building it with a use case in mind, not opened up to the public, so that we could actually get the core functionality working. At the beginning of last year, we actually started to open up and get more customers on. And what happened was, obviously, these are adding additional agents. That's how we kind of measure the success of Dataloop. The more agents get added, obviously, the more revenue we make, but the more people are using the system. And you'll see what happened was we started to convince some people to try it, and then we accidentally sold it to two very large companies at exactly the same time. and without any much planning, they just immediately added all of their agents at once, which is great. Because remember, if you look back, I mean, that was infinitely scalable, right? And we spent a year building that. It was like the Ark, Noah's Ark. And then the rain came. Yeah, well, that's what happened, basically. It mostly broke. And we managed to keep it from completely sinking, but that's pretty much a fair indication. All of the companies onboarded at once, everything broke. You know, and we managed to keep it running, keep the data coming in, but we were in pretty much firefighting mode. And you can see what happens. I mean, it has a big effect on your business when stuff doesn't work. People don't like using it anymore, especially with a SaaS app. If we were doing open source, we'd get away with this. Like, people are willing to invest chunks of time just trying to get stuff working. But when you're selling a SaaS product, you get literally like one go with somebody, and then they'll just leave, and we're done. So yeah, to get ourselves out of that mess, well, we started to monitor stuff. It's not completely a monitoring pitch, but we wanted to understand what the problem was. So we set up another environment to start to monitor things, and we could see the issue was mostly around getting the rights into our time series database. That was pretty much all of the problem. So to solve that, we threw readers in the middle. This tends to be a common story at most companies. You get into massive scaling problems, and so you stick a massive cache in the middle. So that's pretty much what we did. We bought the biggest box we could find, and we stuck Redis on it. And then instead of, in the old diagram, having the metrics workers pick the messages up from RabbitMQ and put them directly into the database, we stuck Redis in the middle, and we split the job in half. And then we could split the writes. So what you'll see on the graph is like a sawtooth. You know, the Redis will build up for an hour, and then the metrics worker will come along and process them and tear it down again. But you can spread cache those writes. Instead of having it go directly into Riak and completely ruin the database, you can spread them out a bit, which is what was required. So we wrote another worker in NodeJS. Unfortunately, it wasn't the only problem. Even though we were adding these workers and it looked scalable, and you know, we had a mechanism for solving the fire problem, we'd added a single point of failure. You know, Redis is not particularly a good solution. You need to put a lot of effort into having multiple Redises and build basically your own resiliency and redundancy into it. Adding just a single memory box and then losing Redis means we lost like an hour of data if the box dies. And that's not cool, right? That's data you can't really get back again. So in addition to that, that was fine, that was buying us some time, but our Node.js workers, they just started to crash, like for no reason. And it was really hard to work out what was going on with them. there's this magic limit in Node.js of 1.5 gigs of memory, where if you go onto a box and look at the supervisor, it'll get up to about 1 gig and you'll just have to cron a restart. So we had lots of cron scripts that, on the boxes that would look for the memory and just kill them. Yeah, memory management was an issue. We couldn't really work out what was going on inside the process. We couldn't inspect it in an easy way. There was a lot of craziness going on with flame graphs at one point, and we found this new tool online that would let us dump a lot of the node stuff, and then that would narrow it down to some library that we pulled in. But you know what node's like, we have like 500 libraries, and they're all crap. So, so there was always something wrong with one of them. We were using Mongo. Obviously, everyone starts off on Mongo. And we were, for every metric that was coming in, we got a few 100,000 per second coming in, we were having to do lookups because you need to work out, especially for alerting, you need to work out what the state of the alert is. Like, you know, it's all very well looking at a stream of data, but you need to work out what the other alerts, the alerts workers are doing, and what the current state of the alert is, if it's triggered or not triggered. And that was putting a lot of sort of pressure on our Mongo database. We're doing like 50, 60,000 queries a second on the database for all the different metrics coming in. So our solution to that again was a massive cache, but this time on the box itself. And again, when you're caching stuff in Node's memory, right, that's the worst place you could ever be, really. Right, if you want to use Node.js for this type of stuff, it's good for APIs, getting data in out really quickly. As soon as you want to store state in memory, it's pretty rubbish. We also noticed that it would start garbage collecting like a lot, and you'd have long pauses, which was pretty crap. And on a single box, so we were on physical hardware, 8 cores, we'd run 8 of these processes. They'd each manage their own sort of 1 gig of memory. That seems to be the maximum it could ever do. It's not that efficient, really. I mean, you've got 8 individual 1 gig chunks of memory in the box, so it can't effectively or efficiently use the full 16 or 32 gigs in the box for the one process. So at that point, we'd had enough of Node.js for the workers, and we started to look at different languages. Luckily, you can't see some of these words because some of them are swear words. So if you ever do get a copy of the thing. But we evaluated quite a few. I don't remember exactly the reasons, but we looked at Go, obviously, as a language to replace the backend workers. Weren't that enamored with it, to be honest. We were mostly interested in the Hecker library, and it didn't look like that was going to bring much to the table. We'd have to rewrite it. Also, it wasn't that cool.
What does that library do?
Hecker, it's a stream processing library. So it's kind of like these other things like Storm. It gives you like inputs, filters, and it does a load of cool stuff. It gives you like a framework for processing metrics that come in. Thibaut actually, where is he? You looked at Hecker. What was wrong with it, Thibaut?
I don't know, I'm not sure it was about Hecker itself, it was more Go against Erlang, I think.
Why did you not like Go?
Sorry?
Why did you choose Erlang?
Quite like Go.
Okay. I think the feeling was we just liked Erlang more. I mean, we were a bit blown away by the whole hot patch. I mean, we're not actually using it, but you know, we really did get it's like most of these things. We like the hot patch, and we also like the ability that you could sort of go in there after having no visibility into like Node.js and going onto boxes and running arbitrary commands or copy and pasted off Stack Overflow. Having something that you could run that was reasonably scientific, go into like the REPL, I don't know what it's called in Erlang, but going in there and actually, you know, inspecting what the code was doing was quite powerful. And I think it was that feature mainly that won us over versus Go. Go again felt a little bit like a black box. You know, you'd write the code, you'd compile it up, and then you'd run it in production, and you'd be like, oh, it's broken again, what's it doing? And then put in more print statements in. So the other things we looked at was C. I wanted to do C actually. Into my Python development to make that go faster, we use C. But apparently we needed like 50 developers if we wanted to do C. Whereas with Erlang we'd need less, apparently. We looked at Elixir, but by that point we thought this is niche enough. Maybe we'll it's going to be hard enough to hire anybody that knows Erlang. And you know, it was always our intention to work with Erlang solutions at some point to get skilled up, and we were a bit worried that if we talked to these guys, we'd need like the one unicorn Elixir developer to come in, and we'd have to wait for ages. So we decided just to go for vanilla Erlang. And then there was Java, and it's a good job you can't read some of the words on there actually, because there's a lot of bad. I mean, we all started life mostly as Alfresco, which is It's all based on Java. It's all open source. There's a lot of XML. In fact, it's 90% XML at Alfresco. So we weren't that happy about going back to Java again. In fact, we banned it at this company. We went full Node and we said we're not having any Java at all. But it looks like that's going to cave because Elasticsearch seems to be the only good tool at the moment. Maybe Riak with the other thing on it. But yeah, we decided on it. It's got good memory management. We proved that. It's quite fault tolerant as well. So we're using supervisor to start it, but things can crash and it will generally recover. We're also using Rabbit and React, so obviously first-class libraries for those things. But yeah, the live code tracing was what I think really won it over. And the fact that we've got some guys that don't mind the Erlang syntax. To me, it just looks like a stack trace. Okay. So yeah, we rewrote the workers. We decided that we were going to take the Node.js one, the most annoying one, the one that kept crashing, and the one that was most visible. I mean, we tend to prioritize things by what customers notice first. I mean, you can have crashes on the other workers, like the alerts workers or whatever else, and things will just get a bit delayed, but customers won't have a very visible gap in their graph. I mean, if this breaks, you know instantly. So we monitor things like metric lag, the time it takes to get metrics into our endpoint, to show on the screen, and then we monitor the API to make sure we've got all the right number of points. And if that ever dips, we generally get complaints because people don't like missing bits at the end. So, yeah, once we decided, Tomaz went off on his own and read a book, I think, did you? Buy a book?
Half a book.
Read half a book.
Paper book.
Hopefully the right half.
O'Reilly's programming Erlang.
I was unconvinced at this stage we'd get anything out of this, because I've seen Erlang. But yeah, he came back and 6 weeks later we had a new worker and it did what the other one did, and it did it better as well. So we don't have any more crashes, or if we did, it was hiding it well. And we managed to reduce our physical nodes, so it's always a bit of a worry spending so much money on hardware. It'd be nice to get things efficient on boxes. So we managed to halve them. So we had, as you saw in the initial diagram picture, pretty much all of those boxes are clusters of physical servers. We've got clusters for the API, clusters for the entry points where things come in, clusters for Rabbit, clusters for Riak, and we had clusters for each individual worker, clusters for the alerts workers, clusters for the metrics. So we were able to basically take our 16, because it had got quite big. I mean, even for the volume of metrics we were running, it seemed a bit crazy to be running that many. And with this, we managed to get it down to 8 boxes, so we halved it, which is quite good.
So did you get a raise, promotion, or bonus?
Fortunately, there's nobody to ask. That's the problem with starting a company.
So how many in the cluster?
So there were 16 of those metrics workers to start with. I think at this point we're up to 40 or 50 physical servers running all of it. I'm still around that because we've added on more services. So the GitHub costs increase because as you have more repos, and the box costs increase and you need 2 of everything. And yeah, this halved it. So I think it's a bit unfair because normally you say, we took this software and we wrote it in this other language and it was twice as good. And you could probably say, well, we took this software and we just rewrote it in the same language and it was twice as good because you knew what it was doing then. So whereas the first time you possibly didn't. But I think this time we had spent a lot of time optimizing it. I think if we had rewritten it in Node, it still would have been crap. So this was better. So we kind of fixed it, and then so we were like running steady now. Things weren't on in flames. People were upselling, and then everyone said, "Actually, that's cool, but it's not good enough. We need more features." It's nice that you guys can take metrics in from scripts, and it's cool that you guys can accept graphite data. But now we'd quite like a tool that the developers can also use, and that means they want analytics features. They want to be able to select this metric and this metric across these boxes where this is this and that is that, and then multiply it by 365 and divide it by whatever. And we didn't have a database that supported a query language or functions. So we were literally using React at this point. We picked it because something had to be stable in the entire thing. And as I mentioned before, we didn't need all the features to start with. So we picked React, and it worked really well. We could just add more boxes. But yeah, we weren't that keen on completely writing a time series database on top of React. It's quite big, and getting involved in the code. And it's got a lot of stuff in there that probably we didn't need. So we started looking around at different options, OpenTSDB, Again, it's Java, so we banned that. But you'd have issues with querying the data. You can fire metrics in really quickly, but actually getting them out, again, it does big range. You can have scans across lots of things. InfluxDB, but at the time that didn't have clustering. Well, when they did have clustering, it supported the sizes of 1 and 3 boxes, not 2, not 4. They just had those 2 options. And now they've removed it entirely, so that probably would have been the end of our business. Would have gone with that. So we continued to look around. We found something. There's a guy in Germany on his own that took React Core and used a lot of the properties of ZFS, and on SmartOS created a new time series database. And so he had it running in production for a year. He benchmarked it. It looked like it would work. And so we started to play around with it, and we started to chat to him. Again, it's written in Erlang. Actually, a lot of the guys have already had this kind of feeling that we wanted to do this already. We liked React, but the only bit we were really using was React Core. And we quite liked the idea of it being quite a small code base to work on and iterate. So we took the decision to go with this. It is optimized for write throughput, so that kind of fixed our problem. We could get rid of readers in the middle. We could just fire the metrics directly in. It started off really crazy. It started off just taking UDP, very fire and forget, and writing them as quickly as possible. You don't send metrics into it via like a normal database thing, like an REST interface. He's developed his own wire protocol, which, yeah, it's a bit crazy. It took us 2 weeks to reverse engineer the Erlang client into Python so you could read it, and I still couldn't understand what it was doing. It uses a certain number of bits and a prefix and some other craziness. But yeah, it's really fast. So, it's really efficient to send data in. It sends things around the ring. It stores the data in a memory buffer first, but when you set the end-val to 3, it stores it in 3 different memory buffers across different boxes. So if you lose a box, it doesn't matter that much because it's going to get written to the ring every flush. It's like, we've got it set to 10 minutes. Yeah, so every 10 minutes. So it's better than an hour, and on top of that, it's clustered. So it's a lot better. It's very fast. I know what the benchmarks were, because the problem with time series is a benchmark isn't the same as another benchmark. The shape of our data is different to the shape of somebody else's. When Heinz was benchmarking it, he had low cardinality, I think. He had few metric sources, but lots of metrics with different namespaces. Does that make sense? We have quite high cardinality because each of the individual agents is a metric source. It's kind of like like a motorway. You've got lots of cars going fast, very fast, like Ferraris on there. But sometimes you've got like Mini Coopers, but you've got 20 lanes. We've got Mini Coopers on 20 lanes, and you have like Ferraris on 3. So we had to do lots of kind of optimizing for that. Also, Heinz, I think he was only using it himself, so like querying the data out just for one user in one dashboard at a time. It wasn't really, he'd over-optimized for the writes. So we went in there, we had to optimize for the reads. We let people do crazy stuff like create a dashboard with 40 widgets across 500 boxes and display all the different series for them. So you can end up with thousands of queries being fired off to the database just for a single click, and then you've got lots of users doing it. So we had to do some extra stuff for that. Again, it didn't give us everything. We needed some other stuff as well, but it did give us that query language. So you've got the SQL equivalent, and it gave us, because it's open source, it gave us all of the cool stuff on top. So there's a plugin for Grafana, if you guys have used Grafana. It's like an open source dashboard. So yeah, we started to play with this. We've been contributing to it. Heinz is our Linus Torvalds of the time series world. He's the benevolent dictator, and we keep contributing. We also do a crazy thing. We run this on Linux. He runs it on SmartOS. So we've produced packages for Debian or Ubuntu, and we use ZFS on Linux with it. So there's a Docker container you can play with.
Are you running that ZFS on Linux?
Yes. Yeah. We're running on Ubuntu 12.04, which is the one true operating system. We banned all other versions. We're going to go to 16.06. Sorry?
Then you have to use Fuse.
No, it's native. So ZFS on Linux now is a...
Doesn't that break the...
No, because you just install it yourself.
Yeah.
I think they weren't allowed to bundle it, although I think in 16.06 it's going to come native because I think Ubuntu's got so much money.
I had trouble with
License
kernel
upgrades.
upgrades on Ubuntu, breaking ZFS.
Right.
When kernel got upgraded.
DKMS will fix that. So when you reboot the box with the new kernel version, it will actually rebuild the ZFS modules when it starts up.
We had a lot of fun with ZFS doing this. Actually, I wrote a big blog on it. You're right. I think there are incompatible license differences. Although I think money gets you out of that. When you're Ubuntu, you just do whatever you want. So they're just going to bundle it and then deal with the lawyers later, I think.
And you didn't have problems with RAM?
So I've got a blog. It's running, so we let, I call it Doggy DB, because Dalmatiner is quite hard to say. We let Doggy take half of the RAM on the box, so 64 gig RAM boxes, it takes 32, and then the ZFS ZIL takes the other 32 gigs, and then we monitor it, so obviously we can see how much of that RAM is being used. It seems pretty good actually. We benchmarked it a lot with FIO, all the utility on Linux, and we were getting, each of the new boxes that we've got has got 4 800 gigabyte SSDs, and we let ZFS manage them all, and we benchmark it over and over and over again, changing all the different settings, and did a blog explaining which ones were the magical ones that worked. And we got about 140,000 IOPS out of the box for for reads, and about 50,000 for writes. It's quite fast. We want to move it to Google Cloud at some point, because they've got some boxes with 8 SSDs that are about 375 gigs. And then you get loads more vnodes and makes it much faster.
I was talking to someone from OpenSUSE last week, and he confirmed that it was illegal.
Oh, what was ZFS thing? Yeah. Hopefully nobody comes around.
I'm not entirely sure about that though, right? Because actually the Linux kernel headers are LGPL, and that's all you need to link against the Linux kernel. So it's great. Who's going to sue them? Oracle?
It's bundled in scientific Linux. They bundle ZFS now, yeah.
Okay. It's quite good actually, it's quite mature. I mean, you've got that or BTRFS. Why you need it is because it uses the compression of ZFS. So you can run this in a Docker container without it, but what it does is, and hopefully Thomas can correct me if I'm wrong, but for every single metric path that it generates, it creates a file up front for the week. And the file's full up with numbers, it's full up with zeros to start with. So when you write that to the disk, it starts off compressed. And then as the week goes on, wherever it gets a new point, it'll update the file. And over time, it will get larger, but it will still be minuscule. Is that right? Okay, so that's why we use it, because otherwise it will allocate the entire chunk for the week for a metric, even if you only do 1 point. And that's quite inefficient for normal file systems. Also, the database doesn't include a lot of the checksumming and other things that you'd normally have in a database. So ZFS gives you that. It knows that it's atomic, so you can't half write something in ZFS. So it doesn't have all that complex, crazy logic. It just goes, you've either written or not. So there's a lot of assumptions in the database that have made it clean. But yeah, you can use BTRFS. If there's a problem and we end up with police coming around and raid us, we'll probably move to SmileOS.
BSD.
Not BSD. Even worse. So
Is that not mature enough then? Is that the decision? BTRFS isn't mature enough.
I don't know, we never really tested it. I mean, it says in the documents, try it. But there were enough unknowns for moving to Linux. Yeah, we need to try it probably. But it's working well for us, so...
No legal issues.
Probably not.
I haven't found ButterFS to be as good as ZFS.
It's about 300 years behind in man hours.
I don't know. But, yeah, it works, so we kept
that
it.
woman has.
Out of curiosity,
Yes.
did you consider, I know this is Erlang solutions, but did you consider Manta conjoined?
Manta?
Manta.
Is that a database?
No, it's a distribution system.
Oh, right, okay.
Instead of Erlang.
I think Manta's a little bit more for kind of map-produced big data kind of
Yes.
jobs as opposed to time series stuff.
We haven't looked at that. We are looking at the moment for at Spark, so maybe that's in the same category. Because we kept things simple. Like we wrote it in Node just to do the basic thing. We should really call that Node stuff the prototype. It got us there quick. We were able to service the customers, but now we're on to the point where we'd like to do it properly and scale it out. Spark's one. We'll probably look at Manta. That's a bit after this. The plan was always to do one database at a time, ideally. So we've done half of this database now. So Heinz had his use case. Obviously, it didn't quite fit with ours, so we had to modify it. So Thomas wrote some C, Erlang interfacing with to C to do floating point support. So obviously, with Heinz's stuff, he could always add or always determine what the value was, whether it's like a byte or a kilobyte or whatever else. And because of that, you can use integers. You can just say, this is 100 of something, and we know it's a byte. that we know it's a kilobyte or a megabyte. Unfortunately, with our data formats, you don't really get that because it's, especially with graphite, you don't have a unit metric, unit measure on it. So you don't know what it is, so you have to store floats, because that's what people have sent us. So we changed it, and then obviously we fixed it, we put it all in, and like most things, it didn't work. So we had to fix it up for our volume of metrics. And now it works really well. So obviously, we needed a new metrics worker again. So this is like metrics worker number 3. The first one being Node.js, the second one being the rewrite from Node.js to Erlang. And that one worked really well, so we had to rewrite it again. This time for the new database. So it would take, hopefully, messages directly off Rabbit. It would process them and put them directly into Doggy down there. So we decided actually at this point, it's a bit unfair, because we've also hired Dave to come and work with Thomas, and we thought, wouldn't it be cool if these guys could work on this project with some senior guys that have done Erlang before. So that's where we brought Erlang Solutions in. So they had a guy sit with us for 2 months on site. Radek, very, very skilled guy, sat with Thomas and Dave and kind of trained up the team. And that was, we'd had to go on our own, it worked. We got some confidence, and then we wanted to do this one properly, so we got some experts in, and obviously it increased the team size by a third. But in addition to that, they picked up some good habits from some senior Erlang guys. So I think that worked out really well. We removed readers as a thing, so we had no more single point of failure. So if we lose a box, we're not going to lose an hour of data. And we reduced the servers again. I knew there was optimization to be done in there. So we've gone from 16 to 2 now, which is good. It's doing the same job, but just with this fire and forget nature of things, it can go much faster. We need less boxes. So I asked the guys, and obviously I'm doing a talk as a non-Erlanger, so I had to interview some Erlangers, what the new cool things were that they found by working with Erlang Solutions versus doing it on their own. And these were a few of the bits. So Lager, apparently it's really good for logging. Do you guys all use Lager? Yeah, I guess it's fairly standard. Pooler, I was really disappointed by this because I saw a library called Poolboy, which I thought was an amazing name, but apparently this one's better. Dialyzer sounds medical, doesn't it? It's, apparently that does type checking. Quick check, that's a bit of an oddity because that's a closed source thing, isn't it? It's like a proprietary.
Haskell, open source.
Oh, is it open?
No, it's free for Haskell.
Yeah.
Oh, okay.
The line is commercial.
You've got to pay for it. Okay, cool.
It's a cubic owned product, effectively.
Okay. Cool. So yeah, apparently
Do
she's.
you have Haskell code?
No.
So quick check was checking your code in Erlang?
Think so, doesn't it?
Yeah, that's something which Heinz started. He has written quick check test for his database, so we just carry on.
So
And
that's.
yeah, apparently, even though it's commercial, you get a free license for open source projects.
So that's what generates your tests automatically from your own code. Is that right? Sounds useful. Rebar 3, it's the packaging stuff, I guess, for putting stuff in, like a package.json. Recon, I don't know if I spelled that right. I only heard Dave say it. He didn't spell it either. But apparently he uses that to go into the record to trace what code's doing, so that's what gives him the visibility. That's how he's able to fix stuff, apparently. And also we added Dave as well. He can't be here tonight, but that was a big improvement. The other weird thing that we did was, obviously we needed to get the data from the old database into the new one. So obviously there's no point having a big cluster if it's got no data in it. So we were able to save a bit of time by reusing some JavaScript code that we'd already written. So obviously we had the ability to get data in and out of the old database. We wanted to reuse that same code for pulling it out, but then interface with the Erlang code. So npm install node elastic, and that was then able to load up the Erlang code. And apparently it uses a safe interface, the ports one rather than the NIF. And obviously that saved a lot of time. We migrated one organisation, checked the data, validated it. We already do a cool thing. So one thing that I didn't mention about the architecture was, if you imagine you're sending metrics in a stream of 1 second at a time, and you're taking it and you're putting it into a queue, and then you're processing it, putting it into a cache, and then processing it again and putting it into the database, you've got a fair amount of time between that happening and it being saved. So what we do as part of the metrics worker is, we will also detect if you have a dashboard open, and we will fire that same metric as a split into your browser via a WebSocket. So, and then the browser will merge the points. So what you're seeing is when you have the browser open, it will load up, pull all of the historic data from our long-term storage. In the old days, it would pull it from long-term storage and short-term storage. So some of it, the last hour would come from Redis, beyond an hour would come from Riak, and then whatever was comes in now since the time the data, the dashboard was open, and the metrics coming in would be a point directly over the WebSocket. So we're merging three things together and deduping them. It's cool because it's time series, so you can't really have the different points for different numbers. Unless something's gone really badly wrong. So we just, with this stuff, we added in a fourth. So when we added in the new database, it literally was a case of adding the service. We could run it in parallel, and it would pull from 4 sources instead of 3, deduplicate all the points. So by the time we were done with the migration, we just turned off the old source, and nobody noticed anything, which was quite a nice thing to do. Made my life easy. So, what does it look like today? Well, we've got better at diagrams. That helps. They're a bit bluey. You can't see much on this, but it's very similar, to be honest. We've got Doggy DB, which obviously talks to the API, and we've got a console, which is the web browser bit. That's also got rewritten, because we weren't happy just rewriting the back end, we had to rewrite the front end in React, like most programs want to do nowadays. We're still using Rabbit as our event bus, and for all the metrics coming in. We've obviously got a better job at sort of spilling things out, but the main thing is we've rewritten that metrics worker, which is sort of the core of the Dataloop a few times. And we monitor it a lot and keep an eye on the performance and use our own dashboards, obviously. We've got to the stage now where it's working pretty well. We don't have errors, it's fast, it's good. It runs on Linux, which is cool. So, what are we doing next? Well, we haven't done anything else on Erlang yet, and we've got all these other metrics workers. I think there are about 13 different mini types of workers all in NodeJS, and we've only converted 1. So we need to, it would be good if we could convert them. They're not causing us a massive headache, but it would be cool if the backend team just had, a common set of libraries shared between them and it was moved over. We're getting asked more and more for dimensions. In my world, people are doing crazy things like moving to containers and Docker, and what you end up with is, instead of it being a single sort of thing that you monitor the thing, but it's got sub-things. And you need to now add dimensions, key value pairs to the stream. You'll get a metric coming in, and you might want to tag the metric with like region equals US West 1, or dynamically. So it doesn't do that yet. We've got functions, we've got a query language. It's better than before. It just doesn't have this other thing. So what we were talking to Heinz about was actually having another service. So Doggy DB is actually Dalmatiner DB is 2 services already. It's the backend, which is React Core, and the ring, and a whole bunch of stuff, the way of getting the data in via the wire protocol. And then there's a front end as well, which again is also Erlang, but that's DFE. That serves up and acts as the query endpoint. So you can scale them independently. You can have lots of query nodes, lots of back-end nodes. The plan for this is probably to create another cluster and use React KB proper, and use that for storing the key value pairs on the metrics. And then have the front end connect up to React KB and use that for the queries. And have it optional so that when you're doing a lookup of metrics or storing the metrics, it goes off, looks up what it is that needs to be pulled back, and then talks to the back end to do the pulling of the data. Make sense? Although we've removed all single points of failure, people don't like rebooting the rabbit fixes. In fact, we draw straws for it. You need to turn them off and turn them back on in the right order for it all to work. So just a peculiarity. And they're not, where most of the other services now are sort of cloud scale, we've got away with a lot of this by running it on physical tin, and they don't get rebooted so often. But if we were to run Rabbit on Amazon and they come along and decide one day just to turn it off, that causes a bit of disruption in Rabbit. So I think we'll be working with Erlang Solutions at some point to try and make Rabbit a little bit more foolproof. So I can go on there and run apt-get upgrade accidentally and destroy everything.
What do you need it for? You not get rid of it, not try and get rid of it completely?
I think so. We're really using the queue. So I guess the moral of this story is we've tried to stick to the minimum number of technologies because we're a startup, and often that's bitterness. We've hung on too late. We went for Node.js across the board for everything, and put it off too long, moving to a better technology that was more suitable. it's the same with the Rabbit stuff as well. We're doing two things with it. It's a service bus and it's a pub sub for messages or metrics. A better solution for the pub sub would probably be Kafka, because that's designed for it, except Java. We banned Java. We probably will we probably will install it. But also we didn't fancy running another service, something that we'd have to become an expert in. And that's the problem with this stuff. Whatever you install, you have to pretty much become an expert at it. So we wanted to keep it small. It's doing everything right now. We'll probably end up expanding it because we're using quite a lot of the features in Rabbit for the routing. Like we've got exchanges and we bind up to it, and it basically uses like RPC over the Rabbit stuff. So it's a better. Often when I attend conferences, you see the madness of Zookeeper and HTTP APIs and service discovery and all of the complexity that comes with managing something that way. You just have a Rabbit box and they just bind and they just get sent a message and they listen on a topic and you just get the message. You don't have any craziness. So we like that about it. As I say, it would be nice if that enterprise service bus was foolproof, like a killer box and not worry, and possibly for scaling split out the pub sub just for the queue of messages. Does that answer?
Well, if you're committed to Erlang, can you not actually get rid of a lot of that and keep it all Erlang?
Possibly, yeah. So we've got kind of another rule at Dataloop as well, which is we only really want to build one thing at a time. And idea, I mean, we also need another database in addition to this one, because we need to be able to store like events. So for that, it's not time series data really, it's not a key value pair and metric path as mentioned. And we were again thinking about, could we build something ourselves? And you kind of come to a point where you want to pick up some services off the shelf that just do the job, that you don't have to modify. And then there'll be some other things that you can't get, like the features of a time series database out there. There are many of them, they're all crap, so we've got to build one. And that's kind of our lifeblood as well. We'll continue to iterate those features in the database and add anomaly detection, add histograms, add all these things that people keep asking for. We don't really want to be in the business of modifying everything. I mean, we could build like an amazing queue service, and we probably will. When we get to the size of LinkedIn, we'll probably go off and build like everything. But for now, it'd be nice if we could have a few things that somebody else built, and somebody else looks after. So, yeah. Oh, and we need to hire more Erlang developers. So I don't know if you guys are looking for jobs, but if you are, talk to Thomas. And yeah, we need some more help with this stuff, obviously. And most of our stack now is Erlang, so the backend workers soon will be all Erlang. Obviously the database we continue to contribute to. Dalmatiner, that will always be public, and we'll just keep helping out with that. There are the additional services we're building. Again, we'll be using Riak. And there's a different team that does all the Node stuff now.
Have you looked at Riak's own time series? Well, I know it's a fairly recent one.
We did actually, yeah. We got onto the trial. I think it was literally that week we were looking to investigate, and we got Basher to give us a copy. Colin had a play with it, and it was reasonably generic. Like, it was another one of these things where it had a lot in it. It was quite big, and it solved a lot of use cases, and it probably could have put events in it and stuff like that. It did a load of things. And the problem we had was a lot of these things need to be split out for scaling, and it wasn't as fast as this for this one thing. So the two bits that we really wanted were robustness, the fact that we didn't have to keep firefighting customers telling us that our entire service is down, and performance, write performance. And this did what we thought.
You've got better write performance on
Absolutely, this would be like a million. This did like 1 million metrics per second in a single box, and you can't get anywhere near that on anything else. So this was much better, but it didn't have as many features. So now we're going to obviously have to go and build other bits. But yeah, we can suffer. We could suffer that, I think. Our main concern was to get rid of that Redis box and have a decent database with metrics that could be queried. That's pretty much it. That's the entire thing. Did anybody have any questions?
Yeah, so assuming you looked at Influx DB in the last few days, because they seem to rewrite it every 2 weeks.
Yeah.
How would you compare and contrast? Because that seems to be anything out there that looks halfway decent.
It does, and they kind of nuked it as well for us because they just removed the clustering support.
No,
from
that's this week. Next week will be rewritten from scratch.
Possibly, they might change their mind. So I know Paul Dix because we met him at Monitorama when we first launched, and he was actually doing a monitoring company very similar to ours before he pivoted to doing Influx. And those guys are kind of doing the Mongo approach, which is make it really attractive to a developer to stick on their laptop, give it all the features and make it very, very easy. Right? It's a Go binary, it has no dependencies. You stick it on your laptop and you get loads of cool stuff. And they're optimized for that. And it was always clustering will be here next week, clustering will be here next week. And every time they find a new database engine, they change it. Like they've had 4 different engines, which means they're completely right for the data. And now the last kind of nail in the coffin for us was, now clustering is going to be taken out. It'll only be put into their SaaS product, and then at some point in future it will be a paid edition that will be closed source. And clustering's hard. I'd prefer to have less features and have something that was clustered that we could build on, that I knew my data was safe, than having something that was kind of like the Mongo of the time series world, where it's brilliant, it's amazing on a laptop, but as soon as you put it into production, you've got production load, it doesn't scale.
So I've played a bit with Influx DB, and each version seems to fall over in different ways. But
Yeah.
how's this? I've not really heard of this. Your Doggy.
Doggy.
How's the performance of Doggy compared with Influx DB on just one server? And
So
how often does it fall over and corrupt all the data?
yeah, so it doesn't corrupt any data from what we've seen so far. There are, because it's been based upon very, very old technology. It uses React core to start with. It uses ZFS, which is new to Linux, but Heinz is running on his own thing. He's basically built a wrapper on top of some very old, well-tested software, and it hasn't got as many features. And to be honest, it's a marketing disaster. I mean, to call it Dalmatiner, something that you can't spell. I mean, it took me 6 months to learn how to say it, and even when I've just started to call it Doggy DB, nobody would ever find it. We managed to get it to the top of Hacker News yesterday, because people click links and I had to type it in. But yeah, I think it needs a rebrand for anybody to get to it. And I also think only having a client library in Erlang might have stifled its and especially an Erlang client. For a wire protocol, it's well documented, but it's completely undecipherable to a normal person. So we've done what we can to get it into a different language, and now that people can see the Python, they can write it in Ruby or whatever else. And we've also made packages for Linux, because it had never been built for Linux before and didn't work. It took us a few weeks just to get the packages building and then change all the paths and other weird stuff. So it's in a format now where it could be.
Performance, does it work? Does it?
For us, yeah. I mean, Thomas, what are the numbers?
Yes, well, if I put the numbers, like we are getting into hundreds of thousands of fonts per second. Yeah, I'm not sure how that compares with Influx, where
Well, you need to test it on the same hardware.
yeah, exactly. So
There are some.
difficult to compare, but
I've not got Wi-Fi. So there are some performance benchmarks on the web for it. He just didn't do.
You say that, but the section where you click benchmarks has just got a blank page.
so like the official benchmarks which Hans puts on his website, he managed to get like 9 million metrics per second on 5 boxes, very fat boxes though. But yeah, again, I'm not sure how you can compare that to anything else.
Do you have a look at Basho's one, by the way?
How does it scale?
They come out with a new time series database
That's
recently.
what I was to say, that
That'll be
scaling is
slower.
really good because
It'll be slower?
the Riak call and then how it distributes on the ring, it's almost linear. Like once you get to that limit of 50, 60 nodes, where we all know that Erlang has a problem communicating all of those nodes together, then you start seeing some limits, but before that it's almost linear.
How would you partition your data? You're just on each metric.
Sorry?
How are you partitioning your data?
So that's the stuff building into Riak call, where you just set how many times it has to replicate each write. So
what were you using for your keys?
we use 3. We use 3. So sorry?
I'm not sure what you mean. You use 3 keys. 3 keys or?
No. So
What keys do you use to store the metrics under? How do you design keys?
okay. So for us, the key is the agent source and the metric path. So
How do you design the metric path? I think that's the question.
that's something which actually customers design. That's where like semantics of your data, like it's sort of is encoded into your path. It's based on how you collect your data.
So if I've got 10 keys, let's say, and they're all going to be on one box, or they're going to be on different boxes because the end of the path
yeah.
is
So Riak call is actually going to make sure that the values are at least on 3 different boxes, and if one of them goes down, it's going to actually hand that data over to another one.
Yeah, I don't know how it goes in. So from my perspective, we get metrics in from two different sources. It's fairly flat. We get basically a metric path and a value and a timestamp. So that's the data coming in. They get split up into messages. They get written to Dalmatiner into what we call buckets. So we have a bucket per agent. So each agent spins up, registers, and creates a fingerprint. There's all these words. So it's effectively a UID for the box that spins up. We pump all the metrics into that bucket, which is named after the UID, and then that stores key value pairs of the metric path and the value. I don't know how that gets put into the V node, which then gets replicated around the rim, but I do know when you set n val equals 3, your data is stored in 3 places.
Okay, so the key is actually your agent, not the combination of the agent.
Yeah, we call it the fingerprint. So in Dataloop, the idea is you start an agent, it creates a UUID and stores it in a file called agent or finger, registers it, and then that's your box. If you wanted to ever move your metrics between boxes, you move the file.
Yeah.
So yeah, that's how it's keyed. But there were some plans because we've had a few issues with that. First of all, we started to have a single bucket per organisation, and then we had the key value metric paths underneath that bucket, and we were hoping to do queries using Dalmatiner to get the metrics back out again. What we found is it's very slow to do it that way, and also, if you ever want to move an agent between accounts with the fingerprint, you could just update the index. So for instance, if you had a box that was in an account for staging and you wanted to move it into production, normally you'd have to wipe the data and you'd have to sort of somehow move the metric paths between buckets, which is very costly. Whereas if you have an agent with a fingerprint in its own bucket, you can just update the index, which account it's in, and then you keep all the data and it'll just move at the top level. So we wanted to keep that, although it's caused a few issues, because like I say, we've got a high width of lanes, and if you imagine we've got several thousand of these agents connecting in now, almost into 5 figures, and each one of those now is opening up a bucket, and then for each of the metrics path within it, it's opening up a file within it. So on some of these boxes, we're having to up the open files limit to over 300,000. So we need to do something. Probably Thomas was talking about having multiple agents within the same bucket again in order to reduce the open files, but we're not there. It's working. We've not reached the limits of Linux yet, but it's going to be a constant thing. Like I wrote a blog about Dalmatiner, which basically, I don't know if it's ever going to get to the point of Linux. Like with Linux, you can install it on a very tiny device like an Android, and you can also run it on an HPC cluster somewhere like a supercomputer. And it's got to the point where they've all optimized it for basically everything. From what I've seen, and this is where the benchmarks are a bit weird, if we just benchmarked it and fired in 1 million metrics per second on a single metric path on a single bucket, we'd get phenomenal results. But when you've got 10,000 buckets and you've got a mixture of metric paths, the context of the performance is different, right? You could measure the context against different databases, and certainly for ours, we've had to spend a lot of time tuning it for our particular width and velocity, and it would probably be unfair because it's going to be a lot faster than a generic database. That's kind of why we chose it. So we'll continue to have a team of Erlangers that specifically optimise for the shape of data coming in for us, and that was one of the benefits for using something that was quite a small code base that relied upon external things, so that we can tune it on top. Makes sense.
If you don't mind me chipping in. So Stephen, first of all, I'd like to thank you. I thoroughly enjoyed this, which is pretty strange, as we had an intimate insight into the work that we've done together. But I think this has been a whole new perspective for me, so thank you for that, very compelling. Thanks for all the questions. I would suggest for all of you to sort of stick around. There's some pizzas needing good homes in the hall here, and generally what we tend to do also is after a couple of minutes in here, we'll just go to the pub across the door to New Loom House and then continue the conversation there. But for now, please join me in giving a big hand to Stephen.